Hello and welcome to our video today on tree diagrams in our series on probability. Now, our learning objective today is to use tree diagrams to calculate the probability of combined events happening. Let's just have a look at a tree diagram and see how useful they can be. We've got to complete this tree diagram. Now, it's about a survey of car owners and the cars they use. So in this bit we've got the 30 and overs and the under 30s. Those over 30 in the survey we had 0.6 of them, and under 30 we had 0.4. Notice how those two figures all add up to 1. 0.6 and 0.4 equals 1. And then we branch out into the next bit, the type of car they've got, and we're looking at petrol and electric cars. And in this survey of those over 30, 0.7 of them had a petrol car, so 0.3 would have an electric car. And we've done the same with the under 30s, under 30s as well. 0.23 of the under 30s had a petrol, and so 0.77 had an electric car. And the thing to note as well is that those add up to 1, each pair of them. And to work out probabilities, we multiply along the branches. So in this case, if we want to find the probability of finding somebody from this survey who was 30 and over and had a petrol car, we would multiply 0.6 by 0.7, and we got 0.42. And same with the over 30s and the electrics, we'd have 0.6 times 0.3, which is 0.18, under 30s and petrol, and the under 30s and electric. And you notice there, if you add up the totals of 0.42, 0.18, 0.029, and 0.308, you'll get 1. Let's have a look at another example where this is useful fact. You've got a bag of sweets, 3 blue, 7 red. If I pick out one sweet without looking, eat it, and pick out a second and eat a second sweet, what is the probability that I will eat 1 blue and 1 red sweet? Well, let's have a look at this problem. Well, first of all, sweet 1. When I pick out a red sweet, I've got 7 out of 10 I can pick. Out of the blues, it's 3 out of 10. That's okay. When it comes to sweet 2, because I'm not putting back the one that I've had in my mouth, I'm left with only 9 sweets. So I've now only got 6 out of 9 on the reds and 3 out of 9s on the blue. So I've taken 1 away from a total, and I've also taken a red one away, but the same number of blue sweets remain. When I've taken out one of the blue sweets, I've now got 9 sweets, but I've got 7 red left and only 2. So how does that help? Well, remember what we just said, you multiply the probabilities together. So if we do that here, our 2 reds, we can multiply them together. We've got 7/10 times 6/9, which is 42 over 90. With our blues, red blue, we have got 21 over 90. With our blue reds, we also have 21 over 90. And with our blue and blue, we've got 6 over 90. Okay, 3/10 times 2/9. So we're looking at this question at these two middle probabilities, the 21 over 90 and the 21 over 90, because they're where we've got 1 red and 1 blue sweet. And we would simply add those two together to get the answer 42 out of 90, which we can simplify to 7 over 15. So the probability that we've taken from this probability tree has been of getting 1 blue and 1 red sweet is 7 over 15. Thank you for watching. I hope that has helped you with your understanding of tree diagrams in order to work out probabilities. Thank you for watching today.